So in this station, we're going to be talking about the planets in our solar system. These pictures are going to show you the planets. This picture right here shows you the 4 terrestrial planets, the rocky planets. There's Mercury, Venus, Earth, and Mars. They're all made of rock. They all have a hard surface that you can go down onto. This next picture shows you the gas giants. So you've got Jupiter, Saturn, Uranus, and Neptune. You can see how they're extremely large, much bigger than the terrestrial planets, but they are made of gas, so their gravity isn't going to be as noticeably larger because they're mostly made of a gas and not a solid. Then here's a picture showing the size of the sun in comparison to the planets in the solar system. The Earth is down on the right-hand side there, just a little dot. Mercury looks like a marble compared to the sun. Speaking of Mercury, Mercury has a gravity that is 0.38 times that of Earth. In other words, if you weighed 100 pounds on Earth, you would only weigh 38 pounds on Mercury. The planet Mercury is only 47 million kilometers from the sun, which that sounds like a lot, but it is less than half the distance that the Earth is. It takes Mercury just 88 days to go around the sun once. It takes it 176 days, these are Earth days, to spin once on its axis, which means that a year, the trip around the sun on Mercury, is shorter than a day, the time it takes to spin around on Mercury. Now, because Mercury is so close to the sun, it's got extreme temperature changes. It's 430 degrees Celsius during the day, and at night it drops to negative 170. But remember, it takes 176 Earth days to spin, so the daytime lasts for half of that. So it's about almost 90 days in the sun and then 90 days in the shade. Because of its closest to the sun, Mercury only periodically has an atmosphere because the sun burns it off so quickly. So it reforms as Mercury moves away from the sun. It has a highly elliptical orbit. And there you go. That's Mercury. All right, Venus. Venus is really similar to Earth, both in size, both in gravity. It's 108 million kilometers away from the sun. It takes Venus about 224 Earth days to go around, and Venus spins once on its axis every 243 Earth days. So again, Venus, a year on Venus, the trip around the sun, is less than a day on Venus to spin around. Venus actually has the hottest temperature of any planet in the solar system because the clouds on Venus act to trap in the heat from the sun and create a massive greenhouse effect. So it's 462 degrees Celsius on the surface of Venus, which is hot enough to melt lead. The atmosphere on Venus is about 96% carbon dioxide, and the clouds are made of sulfuric acid. We didn't know about that until we sent our first probes there and they began to melt, and we're like, oh, hey, what's going on? Oh, look, they're made of acid. All right, Mars is small. It's a little bit bigger than the moon. It's got a gravity that's about 0.376, and it is 230 million kilometers away from the sun. So now we're further away from the sun than the Earth. It takes Mars 687 Earth days to orbit the sun, so a year on Mars is almost 2 full years on the planet Earth. Mars spins on its axis once every 24.6 hours, so it's just a little bit longer than the Earth. In the sun, the temperature on Mars is about 35 degrees Celsius. In the shade, the temperature on Mars is about negative 143. The atmosphere on Mars is extremely thin because it has a weaker gravity, and it's made up of about 96% carbon dioxide. Jupiter is our largest planet in the solar system, and it has a gravity that's about 2.52 times that of the planet Earth. Now remember, Jupiter is made up of mostly gas, so it's not going to have a massive field of gravity. It's 778 million kilometers away from the sun, so it's very cold out there. It takes Jupiter 11.86 Earth years to go once around the sun. So for many of you, in the time that you've been alive, Jupiter has only gone around the sun once. Jupiter completely spins around on its axis once every 9.8 hours, so even though it's the biggest planet, it spins the fastest of any planet in the solar system. The temperature in the clouds is about negative 145 degrees Celsius, and the atmosphere is made up of mostly hydrogen and helium in the same proportions as is found on the sun. Now, there are 4 moons around Jupiter that were discovered by Galileo. The first moon is Io. Io's got a little teeny tiny gravity, 0.18 times that of Earth. It is also, like Jupiter, 778 million kilometers away. It takes Io 42 Earth hours to go around Jupiter, so about 2 days. Its period of rotation is identical to its orbit. Now, if you remember from last year when we were talking about the moon is what's called sync-locked with its orbit and its rotation, which is why we always see the same side of the moon. Io is the same way. In fact, all of the Galilean moons, Io, Europa, Ganymede, and Callisto, they all are sync-locked with Jupiter, so you always see the same side. The average temperature on the surface of Io is negative 130, and the atmosphere is made up of mostly sulfur dioxide because Io has a lot of volcanoes on it. Ganymede was discovered also by Galileo. It has a gravity that's similar to Europa, or to Io. Sorry, we haven't gotten to Europa yet. It's the same distance away because, again, it orbits Jupiter. But here's where we get different. It takes 7 Earth days to go once around Jupiter. So Io takes a little less than 2 days. Ganymede takes 7 days. And again, Ganymede is sync-locked, so it spins on its axis the same amount of time it takes to go once around the planet. The temperature ranges from negative 113 during the day to negative 183 at night. And the atmosphere is mostly oxygen, but it's extremely thin, so you wouldn't be able to breathe it. Callisto has, again, it's small, so it's got a 0.12 gravity. It takes 16 and a half days to go once around Jupiter, and it takes 16 and a half days to spin once on its axis. It has a average temperature of negative 139 degrees Celsius, and the atmosphere is made up of mostly carbon dioxide, but again, it's extremely thin because it's got a weak force of gravity. And the last Galilean moon is Europa. Europa is honestly the second place in the solar system that scientists are looking at where there's a possibility of life after Mars. This is the next best one, and it's because Europa has a liquid ocean, but it's buried under kilometers of ice. So it's really difficult for us to get a sample of. It's really difficult for us to test at all. And the temperature on Europa is negative 220 degrees Celsius. So it's kind of tough for us to imagine what that life would look like. But it's got a weak force of gravity, 0.13. It takes about 3.5 days to go around Jupiter. Its orbit is slightly longer, so you do see different sides of Europa when you're standing on the surface of Jupiter, but you'd be dead, so you wouldn't actually see anything. And the atmosphere is composed mostly of oxygen. So this is, again, why scientists think Europa, after Mars, is one of the best places to look for living things in our solar system. All right, Saturn. The force of gravity on Saturn is about the same as Earth. So if it weren't a gas giant and you were somehow able to stand on the surface of Saturn, you'd feel pretty much like you do standing here on the Earth, because it's only about 1.06 times that of the Earth. But you would be incredibly cold because Saturn is 1.4 billion, with a B, kilometers away from the sun. It orbits the sun once every 29.5 years, so just a little bit short of 30 years to go once around the sun. But it takes Saturn 10 hours to spin once on its axis, so a day on Saturn is just 10 hours long. The average temperature on Saturn is negative 139, and just like the sun, Saturn is made up of mostly hydrogen and helium. Titan, which is a moon of Saturn, is the second largest moon in the solar system. It's actually larger than the planet Mercury. The force of gravity on Titan is 0.14 times that of Earth, so it's got a little tiny gravity. Because of its orbit, it also takes about the planet Titan, or the moon Titan, is also 1.4 billion kilometers away from the sun. Titan orbits Saturn once every 16 days, and it revolves once around its axis once every 16 days. So they are the same. I know that slide says hours, but Titan is sync locked, so this slide is wrong. It should be 16 days and 16 days. The average temperature on the surface of Titan is negative 179, and Titan's atmosphere is mostly nitrogen, but it does contain traces of methane and ethane gas. It also has liquid methane and ethane, which goes through similar water cycles, so it rains methane on the planet Titan. So it's not a fun place to live. Uranus, and yes, that is how you pronounce it. You do not say Uranus. Uranus has a gravity that is 0.88 times the gravity of Earth. It is 2.8 billion, with a B, kilometers away from the sun, and it orbits the sun once every 84 years. So even though your teachers are all incredibly old, we have not been alive long enough, or most of us have not anyway. There may be like one or two on campus that have been here long enough to have Uranus go once around the sun. The cool thing about Uranus, as you can see from the picture, the rings are standing up. The planet is actually sitting on its side. It's spinning perpendicular to the orbit of the sun. The average temperature on Uranus, it takes Uranus 17 hours to complete that rotation, that spin. The temperature on Uranus is negative 224 degrees Celsius, which makes it the coldest planet in the solar system. And the atmosphere on Uranus is made up of helium and hydrogen, but it's also got water ice, methane ice, and ammonia ice. And again, the 97-degree tilt makes it look like it's sideways. And lastly, here's Neptune, which is 4.5 billion kilometers away from the sun and has a gravity, again, roughly the same as the Earth, 1.14. So if you weighed 100 pounds on Earth, you'd weigh 114 pounds on Neptune. You'd feel a little bit heavier than normal. It takes Neptune 165 Earth years to go once around the sun. So in the time that the United States has been around, since 1776, when we proclaimed our independence from the England. Sorry, Mr. Dean. The planet Neptune has only gone around the sun once and then part of a second time. It takes Neptune 16 hours to go around on its axis, so a day on Neptune is 16 hours. The temperature is negative 201, and the atmosphere is methane, which is why the planet Neptune is blue. It is not because it's full of water, it's because methane reflects blue light. So out of all of the planets in the solar system, the one that's looked at as being the best for humans to go populate is going to be Mars. And that's because Mars has a relatively hospitable temperature for us. The pressure's lower than what we're used to, but with spacesuits, we can overcome that. The atmosphere is carbon dioxide, so there are some scientists who think that if you take plants to Mars and you could find a plant that could survive in the cold on Mars, they could convert that carbon dioxide into oxygen, and you could begin to have an oxygen atmosphere. In fact, there's a Arnold Schwarzenegger movie called Total Recall that is all about going to Mars and terraforming it, which is the term for turning it into someplace that's hospitable to human beings. So Mars is the place that we are looking at going next. So I'm going to run through this station pretty quickly to try and save some time on this video because the previous one took so long, but there was a lot of information in it. The electromagnetic spectrum is made up of all the waves that come from the sun. It's got radio waves, infrared waves, visible light, ultraviolet, X-rays, gamma rays, and microwaves. Radio waves are used for communicating through radio and television. The television signal that you receive, even the cable, because eventually it comes out as a television signal, is transmitted through the air. Radio waves are also transmitted through the air. You need some kind of an antenna to pick them up. Microwaves are used for cooking your food, which is why you use a microwave. But microwaves are also used in radar stations, and the way that your cell phone communicates with other cell phones and with the tower is through microwaves. Infrared radiation is thermal energy. So you can't see it, but you can feel it as heat. So if you're looking at a campfire and you feel the heat, or if you're looking at a thermal image of an elephant and you see the heat, then that is a infrared image. Ultraviolet light is harmful radiation that comes down from the sun and can cause skin cancer, which is why you wear sunscreen. It's also present in black lights, like this putt-putt golf place. There's one of these, I think it's called Putting Edge, over in what used to be the Artigan Mall, where you can play putt-putt golf in UV black light, which if you go there once in a while, it's not going to be bad for you, but I feel sorry for the employees because they're going to have a much higher risk of getting skin cancer. X-rays are extremely dangerous, which is why you wear those lead aprons whenever you go to get an X-ray done. But it's important to get your X-rays done because your dentist needs to see your teeth and your doctor needs to see inside your bones in case there's a break or an injury to the bones. Gamma rays are so small that they can pass through the cells of your body and they can mutate the cells in your body. Whenever a star explodes, it emits tons of gamma radiation, and the superhero, the Hulk, is supposedly a creation when the scientist, Bruce Banner, exposed himself to large amounts of radiation and became the Hulk. But in reality, you would just get cancer. Speaking of cancer, gamma radiation is used as a treatment for cancer. They beam the radiation into specific areas to hit the cancer cells and try and kill them because gamma radiation is harmful to tissues. So the wavelength that has the longest wavelength and the lowest energy would be radio waves, and the wavelength that has the highest energy and the shortest wavelength would be gamma rays. All right, lastly, we come to station 6, which talks about the life cycle of a star. Now, all stars, regardless of what they are, start out as stellar nebula. This is a picture of the Eagle Nebula. Then you have the Ring Eye Nebula. Then you have the Horsehead Nebula. This is the Orion Nebula, which is a nebula in Orion's belt. And this is called the Pillars of Creation. This is a nebula that has been photographed many, many times over. In the life cycle of our star, you wind up with main sequence stars like this picture of the sun, and then the sun becomes a red giant, which is, in this image you can see how the red giant star is much bigger than our sun. After being in the red giant stage, our sun turns into a planetary nebula like this one shown here. And at the center there, you see that little white dot? That is a white dwarf, which is what our star is destined to become. Now, it will also eventually become a black dwarf, but there are no pictures of that because they do not emit any light. In terms of a supergiant like Betelgeuse, you're going to wind up with turning into a red supergiant. So in this picture, you can see our sun is that little tiny dot at the top where it says 0.7, and the orbit of Mars in the red giant would be inside of the star. The star would eventually become a supernova, which is an explosion of gases, and then it would become a black hole. Now, the thing that I always hate about Hollywood black holes is they always show it like an outer space tornado. That is incorrect. A black hole would be a single point in space that would be pulling things in from all directions. In terms of the vocabulary, the apparent magnitude of a star is if you took that star and you placed it exactly 10 parsecs away, the apparent magnitude would be how bright that star was. The luminosity is a measure of how much energy is coming out of the star, in other words, how bright it is. The spectral class is a system that was created to relate the temperature to different stars. And speaking of temperature, you've got temperatures coming out as colors. So blue stars are the hottest, red stars are the coldest, and when you wind up grouping stars by spectral class, you inadvertently group them by color, which is why on an HR diagram, if you look at this last slide here, you can see how the stars are all grouped together by color, with red on the right and blue on the left.